Good afternoon, everyone. I want to start by welcoming everybody to lunch today. My name is Maggie Hart-Stebbins, and I'm the Bernalillo County Commissioner representing District 3. I see a lot of new faces today, and so I just wanted to say welcome. We do a lunch every month, once a month, here at the McKinley Community Center. And it's an opportunity for people in District 3 or anywhere in Bernalillo County to get a picture of what Bernalillo County government does. And so we bring in different speakers. We have kind of a core group who comes every month, and then depending on the topic, we have a lot of new visitors. So I just wanted to say to all of you who are new, I would love to see you every month. We bring in the sheriff, the assessor, the county treasurer, the county manager, the jail staff. Next month, I think we're going to do something on McClendon jail litigation. So these are all topics that I think are of interest to all Bernalillo County residents and those of us who live in the city. That's almost everybody in District 3. We often don't really get to see our Bernalillo County government at work. So that's the purpose of these meetings. If you sign up, we'll put you on our mailing list and just make sure that you know who our featured speaker is going to be and time and place. Occasionally we do field trips. Usually we meet here, but sometimes we will go out to our some of our Bernalillo County open spaces and give you a chance to see some of the things that your tax dollars pay for. Before we get started, well, so on the table, here is the announcement of next month's lunch. So it's Randy Audio, our county attorney, and Lisa Simpson, who's been working on some of our jail population initiatives. So I hope you all come. It'll be here. Those of you who are regulars will be happy to know we'll be doing Mexican food again, kind of in celebration of the holidays. So you have that to look forward to. There's a lot of information that we put out on the tables. One of the things I want to bring to your attention, every 6 or 8 weeks, I invite a different District 3 artist, someone who's working in District 3, to show his or her work on the 10th floor of the City-County building. And we do a reception, so you have the opportunity to meet the artist. And this month, it's Wally Davidson. We have, Janice, what do we have, about 50 of his pieces? These absolutely amazing photographs. So I want to invite you to join us Friday, December 5th. 5 to 6:30, come to my office. We have food and beverages, and you have the opportunity to view the work and meet the artist. So, same time, our county probate judge is having a similar exhibit in the same building, so you have the opportunity to do both. So we have, ordinarily we would start this meeting by sort of going around and giving everybody an opportunity to just introduce themselves and talk about what they're doing, but because we have kind of a very important topic and a lot of people, we might do that at the end if we have time. So, and I will be around if you have any questions about what we're doing at Bernalillo County government. I'll be happy to talk to you about that. So, one of the things I do as a Bernalillo County Commissioner is I serve as one of the county's representatives to the Albuquerque-Bernalillo County Water Utility Authority. So I'm on the board that one of the big, I guess, issues we've been addressing over the last 5 years is the jet fuel spill at Kirtland Air Force Base. And about 4 years ago, we, the board, made a decision to hire an outside expert firm to help us evaluate and assess what was going on with that. What the circumstances are and what the Air Force is doing to address the contamination. So, and so the firm we have engaged is Interra. And so we have today John Sigda, who is one of the principals at Interra, who's kind of my point person or the person I go to for information. And what I love about John is very good at explaining to non-scientists like me some of the really technical details of the situation. So I don't want to take up any more time because I know that all of you are interested in this, but I just want to introduce John and say welcome and thank you for being here.
Thank you, Madam Commissioner. Pardon me while I get used to this microphone. First off, I'm going to be careful not to do a safety hazard and someone have to file an incident report. So I'm going to push this back here. Just to be on the, and so first off, we have been supporting the Water Utility Authority for 3 years, just about, and looking at understanding the work that was proposed to be done, the work that was done, and then looking forward. Again, the way we look at the work is from the viewpoint of our water supply, from the Water Utility Authority. Are the investigations going ahead in a way that makes sense for the health of the aquifer and the security of the water supply? So those are the kinds of big questions that we have when we're looking at the science, as we're trying to give some guidance to the Water Utility Authority about what recommendations they could make to the New Mexico Environment Department on how to go forward with managing the bulk fuel facility fuel release. And I'm going to also start. First of all, I want to acknowledge Madam Commissioner. Thank you very much for inviting me, and thank you all for giving me this time. I want to acknowledge my teammates. We have a team at Intera here in Albuquerque that supports this work. And it's various hydrogeologists like myself, geologists and GIS geographers, if you will, that take the data, help us take the data, analyze it, and put it in a way. And my presentation is hopefully very short. The idea is showing you some of the ways that we look at the data so you can see it for yourself. And let's get on with, just about who is Intera. Intera's been a firm here in Albuquerque since the mid-'80s. We've been a firm around the Southwest since the 70s. And we solve people's groundwater and water supply problems. We also do a lot of work over the years on radioactive waste isolation, where you have very hard, very demanding, detailed scientific questions to ask about taking high-level or low-level radioactive waste. How do you put it someplace and keep it safe for a long time? Our work focuses on groundwater, getting rid of it, finding it, cleaning it up, and it also focuses on soils. And a lot of our work is done here in New Mexico, but across the world. So this is meant to be as an update. I'm trying to introduce, I hope everyone can see it. I'm going to sit down just so that folks hear, and we'll go from there. So, as you may know, aviation fuels, 3 different kinds of fuels have leaked into the subsurface at the site, which is this black rectangle right here. We're looking at an aerial photograph of Albuquerque, and this is part of the base, outlined as the bulk fuels facility. The base boundary is right here, and then you have Bullhead Park immediately to the north. So to help you get yourself acclimated. The other thing I want to point out is, of course, Louisiana Boulevard. It's hard to see with all the light coming in, but it's there, believe me. Okay, that might help. But you can kind of see Louisiana going right along there. I hope you can see my cursor. That might be, okay. So, some number of decades, the extent of the leak, the timing of the leak is not known, but we do know that 3 different kinds of fuel leaked in. There is aviation gasoline and 2 types of jet fuel. Aviation gasoline is the one that we're focusing on because of its role in threatening the aquifer health, and that's because it contains this one contaminant concern that you'll have heard about. But the contamination from these 3 different fuels is present as a vapor, as a gas, and it's present as a fuel, which is a liquid separate from water. So it can flow in, and under the right conditions, it flows like water, but it's not dissolved in the water. And then the last type of contamination, it's called dissolved phase here, but really means that the constituents that made up the fuel get dissolved into the groundwater or into the pore water of the vadosome. So when you're thinking about the contamination, you've got 3 different ways of dealing with it. You can measure the vapor, and Kirtland has been doing that. They've also been trying to measure the amount of NAPL from time to time, and they're doing a what you see most often in the press is they're doing every quarter they're measuring the level of contaminants in the groundwater. Now, first of all, I want to point out, you may already know this, is that the contamination, it's been down there for a long time. It has not reached any water supply wells. And the Water Utility Authority has been doing a monthly monitoring using the most precise measurement method for the particular contaminant. It's the first one on the list here. It's called 1,2-dibromoethane, but everyone calls it EDB. And that comes only from aviation gasoline, which was, its production and its use was ceased in the mid-70s. So whatever leaked out up to about 76 had this contaminant. After that, we had other fuel types that did not contain this contaminant, and none of the contaminants from any of those three fuels ended up in any of our wells. And every month, they're monitored. So secure, the water supply is secure. At this point, we're talking about what needs to be done to prevent any problem for our future. So another class of compounds that extends to all three fuels, you might have heard this before, BTEX. It's a group of ones that you'd smell pretty easily. They're volatile. Benzene, toluene, ethylbenzene, and the xylene family. And there are other fuel-related pollutants, but for the water supply security, you really want to focus on ethylene dibromide, EDB, and these BTEX family. And what I have here, you might not be able to see the lettering up here, but these are maps of ethylene dibromide over time. And the left plot, now it's animated, so we'll go through this step by step, but we're looking at back in 2010, each circle represents a well. So, and the colors represent a mathematical interpretation of the concentrations measured in those wells. When you see a well like here with it's just an open circle, it was not detected. So you can see the other point I want to bring out is up here as we're heading towards the Ridgecrest wells. This is one of the first Ridgecrest wells right up in here. That's the closest to it. So the colors represent the level of contamination, and red is higher. Dark blue, which you can see over here on this, which is from quarter 3, the third quarter of 2010. The left panel is the second quarter of 2010. That means it was at or below the regulatory limit, and that's called an MCL. It just means, hey, if it gets above that level, we've got to do something. We're not allowed to have that water in our drinking supply if it has that concentration above this dark blue. So most of it's non-detect, right? Going up to the well here. And what you're going to see is that the shapes of the colors are changing over time as more and more wells are added. And I do want to point out that this is a mathematical interpretation. It's not an actual depiction of the concentrations because we don't have wells in every piece of aquifer here. So as we go forward, this is 2010. 2011, Kirtland installed many new wells, and you can see them, and the plumes extended now. So you have, in terms of our definition, we can say it's gone up here, but we're not quite sure if it made it across Louisiana. Then, so this is 2011, the last two quarters, the last half of 2011. Then the last half of 2012. You can see it's essentially not changed a whole lot. 2013, you can see it changed, but what I can actually tell you is that our GIS guru went on maternity leave, and we ended up with a slightly different mathematical interpretation. But in essence, the plume has changed in general in its internal structure, but not in its length. And the question marks over here are meant to indicate that we don't know the bounds laterally. There are also questions that NMED has been raising with Kirtland about the bounds vertically. How far deep does it, how far down does it go? Now, this last slide is from the first 2 quarters of 2014. And you can see, again, it's not much change. But I want to point out over here, these 3, or sorry, they're more than that, they're 5, I think. 5 green diamonds. And they are new well nests that have been proposed that will be put in the coming months by Kirtland to define that extent. And we'll know whether it got across Louisiana or not. So that work is underway. Okay, that was the EDB in the groundwater. But let's step back for a bigger picture about the contamination. So the plot in the upper right shows the bulk fuels facility rectangle and a bunch of wells in a red line. And it goes from left to right on the same point. So here's in the bulk fuel facility, and then way over here is way down up at this point here, from to the northeast. And we're looking at a cross-section, a slice through the earth. Each of these lines represents a well that was put in by Kirtland over the years. And each of the colored rectangles represents what we call a screen, where the water is coming in. And the screens are different lengths, so they can measure the concentrations, near the water table, which you see as this blue line, and below it, and even further below it. The red line at the top is the ground surface. This is not to scale, but that's okay. I want to just point out, down here, I think the deepest one is somewhere in the order of 100 feet below the water table. So now I'm going to talk about, before NMED called them buckets, and I think that's not a bad way. The different kinds of contamination, what bucket does it fall into? Because each bucket, or a contaminant domain, requires a different approach for cleanup and a different threat to the water supply. So the first bucket is called the vadose zone, and that is simply the chunk of earth above the water table. As you know, there was a leak up here, and you can see this yellow square right here that's representing, in the aerial photograph, this particular yellow square. And so we're talking about the chunk of earth where the El Napo, the fuels, leaked down through the 480 plus feet to the water table. This bucket or contaminant domain is important because it is where the material came from and may still be moving. And in fact, it moved then down to the water table, and that's this red dashed rectangle here, and you can see it inside here, right here. And the red one represents the El Napo, or the fuels, mixing with the water. It doesn't float on top as a pancake, there's some mixing. And basically, what you can think about is all those sand grains that are down there are fighting, the pores between them are fighting for whether they're going to hold water or fuel or some mix. And that's really the issue of coming up with that. And the other bucket is what everyone really thinks about, and that's the dissolved phase, the contaminant in the groundwater. And that's this blue rectangle here. So we have these 3 rectangles, 3 buckets, 3 domains. What we need to know to understand the future health of the aquifer is, one, this yellow arrow represents the amount of mass leaving the vadose zone and coming into the saturated zone below the water table. The next is how much mass is coming out of the El Napo that's hung up with the water in those pores near the water table and going in, dissolving in, and then moving it on its way down to our wells. One of the things that it's important to remember, the only thing that's going to get to our wells, our water supply wells, is the dissolved solutes. The El Napo stopped far short of that. It stopped basically at Ridgecrest to the extent of this, to the best we know, and there's real reason it's kind of, as I'll be showing in a little bit, we have that pretty well constrained over the data. And I want to point out that the data that I'm showing you is straight from Kirtland. We don't have a separate set of data. They provide us with their measurements over time, and we look at that and use that in our analysis. So, questions that I would like you to take away as you're reading the newspaper and talking to people from now on is, okay, in terms of cleanup, we've got to We've got to worry about the dissolved phase bucket, the contaminant in the groundwater, and that's what everyone's thinking about, because that's closest to our wells, and that's how, if it were ever to make it to the wells, that's how it's going to get there. The other, though, is back in the source area, in the vadose zone and at the water table, where the water and the fuels are mixing. So you want to think about each of those requires a different way of cleanup, perhaps, but each needs to be addressed in one way or another so that we minimize the threat to our water supply. Now I'm going to zoom out now into the large scale. This is a 3D visualization. You see the Sandia Mountains here in red, and the Rio Grande Valley. What we have, as you know, this is all hard rock, and what we are sitting on right now is a lot of sediment. Anybody care to guess? The hard rock that's at the top here is below us. Anyone care to guess how many thousands of feet it lies below us? Any guess?
25,000.
Somebody knows what they're doing. 25,000. It's a bunch of miles down. And our aquifer, that the wells, and I'll be showing those in a bit, taps into the top couple of thousand feet. So there's a lot of sediment, but most of it is useless for water supply, the way we think of it now. It's this uppermost several thousand feet, depending on where you are in the basin. And that's why I'm going through this, is to show you about the different parts of the basin have different value in terms of our water supply. So we're going to zoom in now a little bit now from the down. This black rectangle here is the bulk fuels facility. You can see Tijeras Arroyo right here in the Sandia Mountains. And there's a very faint, well, I don't think I can even see it. We'll move on. But there's a faint blue dotted line here that represents the easternmost extent when the ancient Rio Grande was flowing and laying down good sediments. So you can see that it made it way over here close to the Sandia Mountains. It may not be news to most of you, but I want to point it out because this is where the aquifer and the wells that we're worried about are located. So we're going to now stop looking from on high and look as a cross-section. So we're going to take a cross-section basically right along close to I-40 here. And this is work done by a colleague of mine when we both, well, he was at the New Mexico Bureau of Geology. So we see the Sandia Mountains here, and we see a cross-section of different colors going from east on this side and down to the river over here to the left. And in the area of interest is right here where I have my cursor. And the colors represent different geologic units, but the one that most is importance to us is the light orange one. That's the ancestral Rio Grande. That's where Rio Grande was really doing its thing and laying down really good sands and gravels for the most part. There are clays and other things in there. But you can see that in this particular area, it's very thick. It's, by the way, the bottom of this cross-section is sea level. So we're talking about 5,000 feet total, just about over there. And there's several, and the water table is this little line right up here. Let's zoom in a little bit more. And what we're looking at here, ground surface up here, this nice light orange material, the ancestral Rio Grande. The water table is a dashed line right across here, and there's some colored bands. And they represent 2013 extent of the plume. And as you can see, they're very close to the water table, because as far as we know, they're only about 60 to 70 feet below the water table. These purple bars represent, well, I'm zoomed in here, but the purple bars represent the screens where our water supply is coming in. So these are, here on the right, the water supply screens for Ridgecrest wells. You can see up here, the VA well on the left. So these wells pump from a very long thickness, about 900 feet for the water supply wells for the city, for the Water Utility Authority. These other wells, all these other lines over here represent the almost, well, I think it's now over 100 boreholes that were put in by Kirtland to look at contamination in the groundwater and contamination in the vadose zone. The ones that are up above the water table with little rectangles represent hey, we're trying to get an understanding of what's going on in the Vado zone. As you can see, they put in a lot of wells. And you also see that from all those little circles that are helping us map out the plume. So I just wanted to direct your attention to a couple of things. One is that not all this material here is really good, and it's one of the reasons why the water utility authorities put its supply wells over the decades, because it's producing quite a lot of water. And the contaminant plume has not reached it yet, and the wells that are producing our supply of water don't necessarily pump from just the aquifer that has the plume. And in fact, I'm going to go into this now, is that when you look at, and this is a map of data from the USGS, very recent, and it shows lines that represent an average groundwater head or energy level. That's basically, you know that water is going to flow from high energy way up here down to low energy way down here. And you can see it's quite, the number here is 4970, it's quite high. So water is flowing from this way. It's kind of following the river channel right here along part. But the contours are wrapping around over here. And you can see all of these circles with dots. Those are water supply wells. And you can see that, man, most of them are over here in this area where the ancestral Rio Grande sediments are located deep, relatively thick, and good quality. There are wells elsewhere, as you can see scattered here to the west. The plume is right here, and the Ridgecrest wells would be these right over here, but there are many others. And the reason that the contours are wrapped around here is simply that over the decades that we've been producing water from this, we've drawn it down. We've drawn the energy down, so the water's flowing in there, drawn the water levels down. But they've started to rebound, as it's been in the news, I'm sure you're all aware. And if you look at the same USGS set of contours for 4 years earlier, you'd have seen that the depression represented by these little, one little here, 4850, 4850. This 4850 contour was much larger. So why has the water level come back up? One, we're doing a better job of conservation. But two, we realized that mining the aquifer over the long term is not a long-term solution, and so the city began taking water to the Chama diversion, and they're pumping less. So the water levels naturally came up. The interesting thing, and the reason I'm spending some time about this, is it shows you that it's not just Ridgecrest that's over here making this happen, but that these water levels that the USGS put out here are pretty good for the whole thickness of our aquifer here on the western half. But on the eastern half, it becomes, it's a little bit oversimplified. They're actually based on results that the USGS has been monitoring, and the Water Utility Authority and others have been looking at, is that there are 3 separate aquifers, at least, where the Ridgecrest wells are producing from. And the rebound is coming from the deep aquifer, a lot, and also a lot from the intermediate aquifer, and some from the shallow one. So they're responding differently. And what that says is that where the plume is only the upper part of our aquifer, and then we have deeper parts of the aquifer that are providing water to our supply wells that would not necessarily be affected by this plume if it stays shallow. So let's zoom in now a little bit more of contours, and we'll move on from this. But this represents, here's the BFF and the plume outline here. This is a combination of data just to look at the shallow aquifer. And high values are here to the south. Right? The high values are here to the south, and they're here to the east. And so water is flowing to the northeast this way towards the Ridgecrest wells along here. Now, this close contour there is because Kirtland has a pumping well dealing with another groundwater problem there. So they're capturing what they need to capture right in here. And it's in 2012 when this information was compiled from. This is what the story looked like in our shallow aquifer. Unfortunately, we don't understand how that story was over the decades because all of our data came from these screens of our production wells that intercepted 3 aquifers. So it complicates the understanding of the long-term history. But we can use the information that's been gained and understand the flow system is heading, and so it makes sense that the plume looks like this and it's following the contours at that particular time in 2012. And as we get to the remediation part, you really want to change these contours. You want to change their shape so that this plume doesn't make it up to the Ridgecrest wells up here. What else has changed? The LNAPL, I apologize, I didn't explain that acronym. Light, non-aqueous phase liquid, but fuel.
Say it again.
Light, non-aqueous, so it's not water, phase liquid. So it's a liquid separate from water, and this one it's light. It means it's lower density, so it has buoyancy that tends to bring it up high. Oil and vinegar in your salad jar at home, I mean your salad dressing jar at home. More or less. Except now it's complicated by putting a whole bunch of sand in there. Harder to get the oil and the water out together in the right mix that way. So this is a very complicated plot, but it's really meant to show the change. And what we're seeing is time from early 2008 to end of first half of 2014. On the left axis, we see a concentration of EDB, and that refers to the bright purple or pink value that you see here. And that over time, you can see that it jumped up here. And again, all this data comes from data that we've received from Kirtland Air Force Base. Their values that they put in a database that they gave us. So we see it, it jumps from 55, up to 1,000, but now it's coming down. It's coming down very nicely here and getting lower, but it's not zero. At what level do we stop caring about how high it is? Somewhere close to ideally below the MCL. The MCL, the maximum contaminant level, I think. I never get that right. Well, in this case, it's what the EPA says is safe. On a risk basis, you can drink it at that water having that contamination. So this number here is slightly above that MCL. It's not zero, but close to it. It turns out that the MCL is very low for EDB. You may have heard, and it's true, it's a known carcinogen, and it's one of the reasons why this level is so low at 50 parts per trillion. Okay? So it's bouncing around over time. That's the important thing. The red curve is showing the thickness of our LNAPL, our salad dressing oil, and you read it on the right-hand axis. And recently, it's been zero. That's what all these numbers here. And it was up to about 2 feet over the time period that's been monitored. So you see, once it went down to zero, we saw a big drop in the levels of EDB. Now, it could be because the LNAPL, as the water table's been rising, and that's what the blue curve's about, has been redistributing the LNAPL. This area is outside the Kirtland Air Force Base fence. It's just north of the fence, just south of the soccer fields that are in Bullhead. This level here, this curve here, represents the change in water level. And what we can see is from 2008, we're still going down, and then 2009, we start bringing in the water from the diversion, the Chama supply, and water levels have been steadily rising with some seasonal variations. And so that it's gone from a low point of -3 since the start, -3 feet, up to about 6 feet. So it's changed almost, it's increased since we stopped pumping so hard, about 9 feet over these last several years. And part of that is also the explanation of why the LNAPL in this well that used to be there cannot be measured. It just is, though I want to make sure we all are together, the LNAPL is there. it's still producing the EDB. It's just been redistributed so that it can't flow into the well. And this makes it very hard to know then how our cleanup is going. But this is an important thing. The LNAPL's there. There are, and we're going to get into it, there are a lot of different processes affecting that LNAPL. Bacteria are breaking it down. We know that because of the data that have been telling us that most of the fuel is being eaten by bacteria. There are experts far greater than I about that we can turn to if we want to get into that discussion. So some of the LNAPL is actually disappearing because it's being changed into other compounds that are less of a problem for our water supply. But some of the LNAPL is still there, and it's just been mixed up in these pores between all the sediment grains. That's why it's hard for it to get out and into the well. Now, I'm running over. This is LNAPL in the same curve for a nearby. It's in the same area, and you can see how EDB concentration is bouncing over time. It's just going up and down over time. So we have curves, we have wells that when you look at the data, there are wells that it's decreasing, others that it's bouncing up and down. But in all cases, the amount of LNAPL is going to zero. The red curve, in all cases, the LNAPL is no longer observable in the well. And in all cases, we're seeing a rise. Not always 9 feet in the water table, but we're seeing a rise since 2009. Okay, let's bring this home. What is this? So this is the changes in the system that we're seeing over time. I'd like to finish off by going back to our buckets, our contaminant domains, and talk about when you're looking at the news or when you're talking to your friends or anyone else about the problem, what are the right ways of cleaning it up? Remediation. How do we address this? How do we clean it up? For the vadosome NAPL, the fuel left in the vadosome, soil vapor extraction is one method that is widely used, and it's relatively cost effective. And it has been used here since 2009. And I understand, though I'm not privy to all the details, that there's a discussion of an expansion of the current SVE system, soil vapor extraction system, and it's, in 2015, that would expand the area and hopefully remove more LNAPL that may be found in the vadosome. So that's the bucket bringing the material down into our aquifer. The next bucket is where the NAPL has now gotten into the aquifer and it's mixed up in our salad dressing jar with the oil and the vinegar and the sand. And one method that has been used in a number of places, it's been demonstrated to be successful, it's two things. You take air sparging, which means we fizz air below the water table to try and drive the LNAPL constituents out of being LNAPL, make them into a vapor. They'll then move up into the vadosome where the soil vapor extraction wells will capture them. You can't just put a well in, unfortunately, when the LNAPL's there and smeared, as it is with this rising water table. It would be nice if we just put a well in and pump it, and it would flow into the well and we get it out. The physics don't allow that, unfortunately for us. So air sparging and SV is one way. Kirtland is investigating another method. It's called enhanced bioremediation, or basically trying to get the bacteria that are doing a good job on the other contaminants, like the BTEX, the benzene, the toluene, the ethyl benzene, and the xylenes. The bacteria are doing a very good job on those. That's why we generally don't worry about putting up plume maps of that, because they don't get anywhere near as close to our supply wells. What if you could get the bacteria to do the same thing to EDB that they're doing to the BTEX? That's under investigation. That would be another way of dealing with it. Now, what about the groundwater with the EDB and the benzene that have moved out? Ideally, you'd want a remediation that captured it before it got to the water supply house. And that's certainly what the Water Utility Authority would like to see happen. And Kirtland, as I understand it, I'm informed they're committed to install a capture well next year with a plan of adding up to 7 more during 2015 and 2016. We're going to talk about exactly what I mean by a capture system in a second. The idea being is get that stuff and don't let it proceed on to the supply wells. What's going on now is that the USGS is it's finishing up one well nest of 3 new Sentinel wells. The USGS and the Water Utility Authority in Ontario put in 1 new Sentinel well in 2013. And a Sentinel well means, hey, if the contamination shows up here, then we know it's not yet to the supply wells, but it's closer. So now we have, in essence, a warning, an alarm system. The USGS is putting in 3 of those. They're being funded by the Air Force, and that's good news. And that work, I know the drilling is ongoing right now. The USGS will also take those wells and characterize. We need to make some measurements of the aquifer properties in order to design this capture system. So let's talk about that. So, you want to capture the plume, and in this case, you can see here, we've got 3 plumes. Red for shallow, blue for slightly less shallow, a little bit deeper, maybe 40 feet below the water table, and deep, in this case, is 60 to 80 feet. So these are based on contours that were on the data from Kirtland, and the dots in each one just represent EDB. What we want to do is make sure they don't get past the line of black dots to the Ridgecrest wells, which are further up gradient. So what we have is plume wants to move from the lower left-hand corner, and I've got to make sure, from down here towards Ridgecrest over here. So there's groundwater flows heading towards those wells. We saw that with the USGS contours and the shallow aquifer contours. What you need to know is how close to put each well, how high, how hard to pump it, how deep to screen it, and those depend on understanding properties of the aquifer and this regional flow field. So what the USGS hopefully will be providing is some of the information, and that down the road, a combination of Kirtland and others will provide the full range of information that's needed to design the system. So the Water Utility Authority asked us earlier this year to take a look at some example systems. Could it be done? Could you capture this plume? And what, given the uncertainty we have, we don't know the properties that we need to put into the design, but we have some guesses about the range. So we looked at the range, and we looked at how these example systems might behave. So I can tell you that our work showed that there are systems that will behave and capture all the particles for the range of uncertainty that we understand today about the aquifer and about the regional flow field. I'm not going to show you that picture because that's not as interesting. If we don't get the science done, and this is one of the things I'd like you to take home, is that it's important to get these measurements done right, because you can design a system and watch the particles. We're seeing over time they should be pulled in by the black circles, and if you don't set the design right, in this case the pumping rate's a little bit too low, so some particles get through. I want to reemphasize, by changing the pumping rate for this particular set of characteristics, none of the particles get through. So this is really what Kirtland is working on, as I understand it. Certainly what the Water Utility Authority wants to see happen as soon as possible. And to wrap up, there are remediation challenges. Again, what I would hope you take away is that we're going to deal with bucket number 1, the groundwater plume of the EDB and the benzene. Make sure that that doesn't make it to the wells. And as I mentioned, there are new well nests being put in to better delineate the extent so we know just how far it's gone. The Vadosone El-Napple, there are some questions that need to be answered about how much, what's the composition, is there any EDB hung up? Not all El-Napple is equal for us in terms of the Water Utility Authority. The jet fuel El-Napple is not as much a problem as the aviation gasoline El-Napple, because that's the one that has the EDB. So if the bacteria are doing a good job on most of the compounds, then that's not as big a worry. What is the worry is the EDB. And then again, how much El Napo and how much EDB in El Napo is making its way from the Vado zone into the aquifer. So ideally, expand the SVE system would be a great way to just begin to deal with that. And the El Napo in the saturated zone, things are changing. You saw how much the water table is changing, so the system's changing in time. And there's no reason to right now expect that the water level won't continue to rise. So we'll continue to see some smearing, and we need to understand then how that El Napo is being moved around, and so we understand its composition and its extent, so we can better address some interim measure that the Water Utility Authority would like to see, to identify and implement an interim measure that would deal with getting that source out of those pores. I mentioned here that it's important for us to know scientifically what the flux, the transfer of mass from El Napo into the dissolved phase of the groundwater is. And it's also important for the scientists to work out advection is the process that carries the solids. The solids are there and being carried down a river. How does that compare to other processes like absorption to grains or degradation? Which one's faster? Which one's going to win in the competition? So I apologize for taking over long, but I really appreciate your attention. I'm grateful for your questions. Thank you.
Yeah. I just have a question. The original fuel spill, was this avgas that was just spilled out on the ground, or is this leaking from underground storage tanks? And since there was probably a huge concentration of the contaminants in the topsoil, how long has it been since all of that was removed, or has it all been removed?
It's a great question. Let me repeat it. How did the fuel get released? Was it just a big spill? And then or a continuous, and then also the soil that's near the surface, what happened to that contaminated soil? So I know, my understanding is that there is an underground pipe, and that pipe that went from the offloading racks where the fuel came out of the tanker trucks or out of the rail cars and went underground through the pipe over to some tanks, and those tanks got some holes. The size of the holes probably changed in time. So the rate of leaking, it happened below ground, so there was no, as best I know, I don't know whether you could even see any sign of it happening at the surface. But it was leaking, and it would have been every time that they pushed fuel through that pipeline. And I couldn't tell you how often that is. Now, the second part of your question is, yes, Kirtland has gone, the Air Force has gone in there and removed, well, I'm going to have to turn over to one of the Kirtland, but they've removed quite a bit of topsoil. And I would imagine they've followed NMED's guidelines for saying, okay, if the soil has a concentration above this level, take it out and send it for treatment. And if it's below those guidelines, you just leave it, because it's not going to be a threat to the water quality in the future. Go ahead, sir.
Thank you. Got a couple really short ones here. Are the CDC's and EPA's maximum acceptable level of detectable EDBs the same?
Okay. Okay. Let me one question at a time, because I'm old and I want to get it right. Are the CDC and EPA's levels of acceptable concentration, and I want to separate that from detection, because that's an instrument, that's a laboratory issue. How low can I go? And they can go very low. They can go way below the MCL. They can go, the MCL is 0.05, and I believe the detection limit is like 0.01 something, so down to about 20%. Now, that's laboratory. I don't know of anything about CDC, so I can't answer that. But EPA is the authority that rules here. Our levels are EPA's levels.
Okay, and how many feet are we now from between the EDB contamination and
from the known well,
number 5?
So where we absolutely know what the most what I would call the down gradient means downstream well with EDB. I believe it's wait, the plume is like 4,000 feet. Someone out here that knows. So it's a couple of thousand feet more, or is it 4,000 feet? Rick Sheen from the water utility.
4,750 feet.
That's the plume length, or that's the distance to Ridgecrest 3?
That's plume length 6,000, 4,750 feet is from the monitoring well, the known
Good.
sample.
So the answer is from the well with the detection to the Ridgecrest, nearest Ridgecrest well, about 4,700 feet yet to go.
A
And it's
little
all,
less than a mile.
yes, sir. Little, yeah. Yes, ma'am.
At another meeting, I heard that, one of the chief concerns about the Ridgecrest well being the closest is that it is kind of the star of all the city's wells, if I'm correct, in that it has the lowest concentration of arsenic. Is that, anyone else?
Yes.
heard this too?
Okay, so
And therefore, some of its water is used to dilute the arsenic in the water.
Okay, good question. So the question is, when you talk about Ridgecrest, this well field, is it special? Do we need to be more concerned about it than other well fields? Is that a fair enough way? And it does have low arsenic. That's absolutely true. And arsenic is a problem. But it is not the only, I mean, that, if you think about all the wells along there in that ancestral Rio Grande that goes all along north-south through the city, they're all producing at a fairly high rate. Not all of them, but many of them. So the Ridgecrest is a very important well field, and it's important because it's a really good producer, and it's important because it has low arsenic. Rick, is there anything else we need to add?
Yeah, right next to you.
Oh, good.
I can take on that question. Rick Sheen, water quality hydrologist with the Water Authority, actually. The production wells in the distribution area where the spill is located, none of the wells actually feed any other distribution areas. Actually, all the water it has is from that area. Ridgecrest 5, it's a high yield, so it's high production, low arsenic. However, its flow is restricted to where it distributes within that zone. We actually have 3 other well fields that we use in the time of a higher demand, and actually we don't pump wells that are above 8 parts per billion for arsenic, with the standard being 10.
So there's no way to mix low arsenic water with higher arsenic water in the system?
That's not how we're doing it with the system. We're pumping wells that have below the standard. And we can do that up to twice the average demand.
But if Ridgecrest were to be shut
We-
down, would there be enough low arsenic water
Yes,
from all the
yes,
others?
we're able to get more surface water, but if we're not able to increase the surface water production, we can also take from other production wells north of the site. So yes, we have some interconnectivity. We can pump from the northwest to the southeast, and vice versa. So.
Yes, I have a question about the bacteria. Is it injected in, or is it already resident in the soil area? And
So the question
the next
is-
step would be,
Okay.
well, I'll ask it when you're finished.
Okay, so the question is a good one, is the bacteria that are eating, if you will, metabolizing the BTEX and other compounds, contaminants associated with the fuels, were they injected? No, they're actually part of the soil. They were there to begin with, and they took off once they got that food source. But enhanced bioremediation, and Dr. Bodor is here from the Air Force, not from Kirtland, but from an Air Force, and she is an expert in this. So in terms of the success and failure, and whether you want to inject other species, it's been done. I know whether it works for here, I cannot say.
The next question would have been, have we foreseen any unintended consequences of this bacteria growing in order to compensate or to eat up, let's say, the existing pollutants? In other words, once they finish their job, what will they do then? Will they die off?
Yes. So if those bacteria that are working on the El Napo now, They will die off. It won't be anytime soon. Depending, because we actually, it's a hard thing to say, because we don't know how much got spilled. We don't know how much got released. And it would be a very interesting calculation to do. But in terms of, fuel spills, they're part of America, the Western civilization, right? We have fuel spills all over, and I think that generally it's not a big problem. But I don't want to get into, I would direct your attention to Dr. Bladour or someone, if you ask her that question. She probably has the literature much
Way over my head.
Well, no, she's very good at explaining things.
Thank you.
Don't worry. Yes, sir.
Yeah, I've only worked 150 oil spills. My fortune was they were on water. This is a much more complex thing. And I hear experts from one side, I hear experts from the other. We used to go to the EPA. In fact, EPA was the regulatory authority. Almost every spill I worked. It strikes me that EPA is somewhat absent from this process, and I don't know why that is. The other point I would make, the well system, while it was pointed out, are in fields, in many cases, that water has been redistributed throughout the whole metropolitan area to merge it. For example, in the past, it was used to bring down the arsenic levels. So this is something that's not a little local problem right down there. This is an entire metropolitan area issue that needs to be looked at. In that light, I've heard some people who are much more expert in this than I, including you, and I'm not throwing stones at your analysis at all, but it would strike me that maybe bringing in some of these other views that are based on perhaps different data, different models, whatever, kind of give a balance to how gloomy the picture is or how bright it is. So, and those groups are out there, we know who they are.
So if I can get, if I got your question correctly, sir, is why isn't the EPA more directly involved in this? It was, in your experience, directly involved with other oil spills that you worked
Overly
on.
involved.
Yeah. Be careful what you wish for. Yes. Is my understanding, and we have people from NMED here that I would ask you to direct your question, but in essence, the regulatory authority that governs this kind of fuel release has been given over to New Mexico Environment Department. And that's where EPA will support them, and they are supporting them. They have given them monetary and technical support, and to the best of my understanding. So that has been, EPA is involved and supporting NMED, is my understanding about that. As to the other data, all I can tell you is that the data that I got came from Kirtland, and I think that's really the only data set we have. In terms of your question about manipulate how the water system was distributed, I urge you to talk to Mr. Sheen behind you there. Yes, ma'am.
My worry is getting the information from Kirtland, the person that was, the group that was responsible for the oil jet fuel spill is kind of a problem.
I don't see that as being a problem because I've worked on remediation projects elsewhere. The remediation of groundwater, and there are lab protocols. Basically, EPA and regulatory agencies have built up an infrastructure of looking at and setting, and NMED tells them, you will sample the water this way, and it will, so there are protocols that get followed, and there are ways of checking on the quality of that data that should be done. And
Right, but they were responsible, and it's gone back many years, and they haven't done anything about it. So it doesn't give me much confidence in what they report.
I see. Well, I don't know that it helps you any, but the data that they've given us to look at, we haven't gone to the lab results or looked at the sampling protocols, but it makes sense to us. I don't know that would be my first priority concern. I would say that's not my first priority concern, but I understand, the fact is that they are devoting a lot of effort to it, and there are people here that might be able to speak a little bit better about that from either NMED or the Air Force. Move over, this gentleman's poor arm is
John, let's imagine that you have just been appointed by the governor as the new head of the New Mexico Environmental Department. What would be the most important things you would like to see happen to protect Albuquerque's water?
Well, as a ratepayer?
As the person, the buck stops on your desk, what do you want you to do?
I'm a resident, I've got kids here, and like the Water Utility Authority, I'd like to see the dissolved phase plume intercepted, captured as soon as possible. And I'd like to see then the other two buckets, efforts get underway as an interim measure, and I think that's what's happening. We've got SVE discussions for expanding it next year, and the El Napple in the saturated zone is the bucket that I believe there's still more discussion to come, and I'm not sure about that timing. And so I would, if I were to follow your question, I would accelerate that timing the best that I could.
We need to go faster. Go faster.
How many people here would like to see this process happen faster?
But we need it to happen correctly and cost effectively. And, you know, and there are ways of doing it. Cost effectively is and that's why we could, like the capture well system that I showed with the particles leaking through, we could go fast and furious and punch some holes in and start pumping. But then 10 years later, we found out it snuck by. So, yes, and so they are, and look at the way, as I understand it, their phased approach. They're going to put in one well, start working on testing that, and they'll put in some more wells in 2015 and 2016. That seems pretty reasonable to me. And the Water Utility Authority is behind that, by the way. Yes, sir.
If you are, the if question like he proposed, if you were buying a home, would you buy a home in the Ridgecrest area?
Absolutely. I like the Ridgecrest area. I used to coach and play soccer on those fields down there, and I wouldn't have to go so far. My way of thinking, but I deal with these problems all the time. There is no repercussion above ground. The contamination that's in the vadosome is on the base. It hasn't, in the El Napple, as far as we know, if it's migrated, it's migrated down and then across laterally, near that water table interface. So no El Napple is anywhere close to being ground surface, to my knowledge, of any home. And the vapor that might come from that El Napple, they've already made measurements and they've looked at by having right there on the base of the BFF, the Not Best Friends Forever, a bulk pool facility. You already know this joke.
Right?
Yeah. Thanks. They move that soil out, and so we don't expect it. But they are monitoring. I believe I've heard that they're monitoring for their workforce, that the vapor coming up would not be an issue for them. So, long-winded answer, I wouldn't, personally, me, sir, I wouldn't worry.
It's not moving towards the Ridgecrest area? This contamination?
Well, I'm talking about the Napple in the, so we got stuff that's deep, and you saw which way the plume's going. It's going
Can you go back
from,
to that slide?
yeah, let's go back to that slide.
Just give them the address.
So very carefully, BFF here, Bullhead Park here, and Louisiana right here. So there's a contamination at 500 feet below ground surface. And I didn't go into the details about the geology in that 500 feet, but you know, where the Napple went loose, got into the subsurface, was over here. And so it went more or less down. It took some detours, but there's been no Napple ever discovered at high elevation outside the property of the Kirtland Air Force Base.
So which of those three is where it's dissolved in actual groundwater?
All three, and I didn't do a good job.
Oh, because you said there are three
different levels. Well, no, and that's a really good confusing point that I made. I confused people unintentionally. these represent intermediate, shallow, intermediate, and deep in that upper aquifer. The plume's only in the upper aquifer and not in the deeper ones. All I wanted you to understand was that the Water Utility Authority pulls water from the deeper aquifers, and I can't tell you how much it pulls from each. I don't think anyone yet can
But
tell
all
you.
3 wells are being tested, monitored.
The water that comes out is being tested every month, absolutely.
But at all 3 wells?
Well, the screen mixes it all together, so it will find it, yeah. Any rate, we got some other questions. Yes, ma'am?
I just want to clarify the question about the Ridgecrest area. And the Ridgecrest wells, which are the ones that are most immediately threatened, do not service the Ridgecrest area. And that's an important point of confusion. The Ridgecrest wells actually are blended with water from all of the wells because they're so low in arsenic. But this is not really a problem in any part of Albuquerque. It's a problem for the whole region, for the whole city. That's, the Ridgecrest wells, which are the ones that are the most immediately threatened, do not service the Ridgecrest area of town. That's an important point to make.
That's okay?
Yeah. Yeah. The Ridgecrest well that you're referring to is at Zuni and San Pablo.
We can pull the map up later. For those that really want to know where the Ridgecrest well field is, I can show you on the computer. Any other questions? Yes, sir.
So, there's all these, well, first of all, I think, we're beyond the point of data collection, and Pump and Treat should be going full speed ahead. We've got all these wells at all these different depths and locations, and so you find the ones where it's the highest concentrate, and you just start pumping, and you adjust your flow rates to see what works best. You have a well at this depth here and a well at this depth here, and this is the way things are done. You start doing it, and you start adjusting, and so the pumping, the actual treatment wells serve a dual purpose as, test wells, experimental, the whole bit. And I guess the question that goes with to you is, at this point, is everything you're doing devoted to helping Kirtland and prodding Kirtland to do this?
Great
Just
question.
get going.
So the question is, why, there's been a lot of years of data collection, why don't we get some capture or some action?
And learn
going on,
from...
And learn from that action and do it in a stepped or phased approach so that we get something in the ground as soon as possible and begin to learn, looking at how that's changing the system, and then follow up on that. And then I'll come to your last question later. And I believe that it's been a long time with the data coming. From the water utility viewpoint, key is to get that, just like you, just like I want personally, get that capture zone, that capture system in ASAP. But, get it up so it doesn't get past and get any closer. Ideally, don't contaminate any new, fresh, clean water, right? That's what we want. We want to preserve what we have. So aim for that. That would be the Water Utility Authority's viewpoint. So that if and I don't know where the Kirtland is proposing to put its wells. That hasn't been shared with me. But if they're able to catch the leading edge, and they're talking about a stepped approach, put one well in and follow it with a number within the next, less than 2-year period. So scientifically or engineering-wise, I think that's a reasonable approach, and it sounds kind of like what you have suggested. And then your last question is, am I pushing Kirtland on behalf of the Water Utility Authority? I think that we have worked with the Water Utility Authority in devising, and we write, when the work plan comes out, we write comments. They get sent to NMED from the very beginning, from the very first work plans that were put out in 2000 No, I didn't get started until 2010, I think. So it would be the 2011 work plans. May be wrong by a year, but that's whenever the current contractor came on board, they put out a set of work plans. And we have been constant, and that's really the Water Utility Authority saying we need the technical expertise. So we've been there from day one. I think that I would ask my client to judge my performance, or and that of my colleagues. But I'm glad that we've been able to support them, because I think we found some stuff that's important for the Water Utility Authority to understand and to communicate to NMED and ultimately to Kirtland.
So if someone were to ask you right now where you think the first couple of pump and treat wells should go, would you have an answer?
Somewhere over at that leading edge, so that it doesn't get out into any, that would be kind of my common sense approach right there. Now, there may be some,
See, and that's,
but there could be,
see, sometimes common sense is great, you know, and that
My dad
we
says
reach
so.
the point where we have enough information to make these common sense decisions.
okay. All right, any other, maybe, I think we're done. Commissioner Hart-Stevens, thank you very much for the opportunity. I'm sorry, I sort of took over here.
Thank you, John, taking over is what you meant to do, so thank you for volunteering your time here today. I really appreciate it. Let me see. A couple of issues. I absolutely agree. This is not just a Ridgecrest. This is not just a Southeast Heights issue. I think everybody in the water service area has an interest in resolving this. Secondly, I think your question, ma'am, about kind of prodding the Air Force. You know, the reason that we hired our own outside expert was to give us that expertise to evaluate the information that was coming out of Kirtland and NMED. And I have to say, in the last year, after I've been on the Water Utility Board now 5 years, I've seen a lot more action by NMED and the Air Force. I think it's kind of a new focus on this, a new willingness to work with us. You know, having John and Intera in those early years and continue. It is so important for us as Water Utility Board members to have access to unbiased information. And I feel that as a member of the Water Utility Board, I represent the public and the water users in this issue. And so, you know, we've got some people from NMED here today. I want to thank you for coming. You know, thank you for your willingness to engage. From Albuquerque, which is the Air Force Civil Engineering Group. I'd like to introduce Dr. Adrienne Bador. She is, she's just been a breath of fresh air. I think Bodie brings really world-class technical expertise to this, but also understanding and being able to respond to public concerns. So really welcome your being here. Anyway, it's an ongoing issue. I'm hoping in the next couple of months we'll see some really significant progress. And hopefully I'll be able to report back to you that really has happened. So with that, again, I want to thank you all for being here. I'm happy to answer any questions. You know, the county's been in the news. We've had some good news lately about our jail population. Always happy to talk about that. But I'll just be here afterwards if you have any questions or anything you want to talk about. So again, thank you. I hope I will see all of you next month. Of course, you're welcome, and we'll see you back here